Hello, welcome to the course Data Modeling and Management. We are in the topic of data distribution, and in this lecture, I will discuss about CAP Theorem. So what is CAP Theorem? CAP Theorem is also known as Brewer's Theorem, and it discusses about the three important properties, which is consistency, availability, and partition tolerance. The theorem states that within a distributed database system or within a network shared data system, we can only guarantee 2 out of 3 among these properties. Let's have a quick look about these 3 properties together. We will look at the more detailed example in later slides. Okay, first about consistency. Consistency property states that within a network of distributed data system, we will always have a single up-to-date copy of data across all the nodes. That means accessing data from any nodes in the network will return the same data at the same time. How about the second property, availability? Availability guarantees that node failures will not prevent other nodes that do not fail from operating. That means a failing of one node will not prevent other nodes to also fail. Other nodes can still operate and return data or give response about the data. Then the last property, which is partition tolerance. In the partition tolerance properties, it states that the system would continue to operate whether or not we have a partitioning due to the network failure. So that means only the nodes that fail or are in the part of the network failure nodes, they will not be able to operate, but other nodes will still operate. Okay, let's have a look at consistency in detail. Remember, consistency means that we will see the same data at the same time, whether we access data from any nodes within the distributed system, right? So let's look at this distributed data example. The pink node here refers to a node within the distributed system. So let's see here. First, we have an input with the data value math at the time 103. And later, we have another update here at another node in the network, which update the data with the value art at the time 104. So later on, okay, if you access data from any other nodes, let's say here, that means we are retrieving the data. We should see the new updated value art wherever we access the data. So that means a read operation on a consistent system should return the value of the most recent write operation. So this is the consistency property. Next, let's look at availability property. Remember, within a distributed system, availability ensures that the system remains operation at 100% of the time, meaning that whenever a user submits a request, the user should always get a response. It might happen that some single node may fail, but it should not prevent the other nodes to operate. Okay, let's see this example. Suppose this node fails. User can still get the answer, the response to his or her request by accessing from other nodes. The system should still operate and return user response using the data available from other nodes. The last property, partition tolerance. This discusses about the case when a network failure may occur, and that divide or partition the system, the distributed system, into two or more partitions. But the property guarantees that the system would not fail even there exists a network partition or a network failure. That means the system will still and will continue to operate and to respond to the user within that partition of the network. Let's look at more detail in the next slide. From this example diagram, you could see that there exists network failure here, right? And with this failure, it make the system to be partitioned into two parts, this and this. And that means connection between these two parts are not possible during that time of the failure of the network. But even this network partition occurs, the partition tolerance guarantees that user of each partition, of each part of the network, would remain operating the system, accessing the data, use the data, perform data operation as they want. That means the partition would not cause the whole system to fail and would not cause the system to stop their operation to the users. Of course, there might be limited functionality or something, but the system would remain servicing to the users and give the data response back to the user. And once the network failure can be resolved, of course, data synchronization or whatever would take place later on. Okay, so let's have a look at the CAP theorem as a whole. Remember, C for consistency, A for availability, and P for partition tolerance. The CAP theorem states that with the presence of network partition, that means we cannot avoid network partition, right? It's something that is uncontrollable, out of the control by us. So when network partition may happen, we can choose, or we have to choose between either consistency or availability, meaning that you can have only one, you cannot have both. If you want your system to be consistent, then it may not be available. But if you want your system to be available, it may not be consistent. What does it mean? Okay, look at here. In this example, we are saying that network partition is something we cannot avoid, right? So let's say that there is a partition here, meaning that now we have separated the nodes A and B. They are not connecting now due to the network failure. And if we choose to have the system to be available, that means we continue to give service to the user. Okay, user can remain using the system, accessing the data. And it can happen that users of this node A would make data update with Mango. But with this update and with the network failure, it's not possible, right, that the synchronization of the update would happen to node B, meaning that user of the node B, they still access and use the system because we want availability, right? So user of the node B, when they access the data, they will not see the newly updated. So they may see the old data with Apple instead of Mango. Okay, so this means we choose availability, but we lose consistency. On the contrary, if you choose consistency, right, that means you should not allow any update to the system while network partition occur. So it means the system will not be fully available. It is available in the sense that you may allow read operations, but maybe you don't allow write or update operation. So consistency and availability cannot happen at the same time when there exists a network partition. Okay, so let's look at each case in detail, meaning that we choose 2 out of 3 here, right? So the first case is we choose CP. We choose to have our system to be consistent and partition tolerant, meaning that whenever there exists a partition tolerant, okay, we want the system to be highly consistent. But that means whenever you access the data, you can always guarantee that the data returned from the system is a consistent one. But it may happen that for certain cases, the data will not be returned or the system may not be available because the system wants to make sure that under the network failure, if you respond back to the user, some data may not be well synchronized. So instead of answer something to the user which may be inconsistent, the system may decide not to give an answer. Then the next case, how about AP? Meaning that we choose to guarantee availability and partition tolerance, A and P. Meaning that the system will be highly available, right? But with the presence of network partition, when the system is still available, users can still perform data operation, meaning that it can happen that users of different nodes, different partitions, may still work with the data. And that makes data of the 2 partitions or more partitions to be inconsistent, right? Because it's not possible to do any synchronization at the moment, but the system is still available, allowing user to perform whatever operations they want. So in this case, we say that data and system is available with inconsistency. So in summary, from the CAP theorem, we are saying that in a system, we may suffer from sometimes due to network partitions. And we need to trade off between consistency and availability. However, this is not a 0 and 1. This is not a yes or no answer. Actually, we can trade off in a sense that we can reduce some degree of consistency to get some more availability. So these can be balanced a little bit. So if we can tune this to get less availability but more consistency, or to get less consistency but more availability, should not be the case that totally unavailable and totally inconsistent. Here comes an interesting question. So, which one should we choose for our system? I mean, distributed system. Whether we should choose AP or CP. Network partition is something you cannot avoid, right? So P will still be there, okay? So whether with the existence of partition, network partition, whether you choose your system to be available or to be consistent. The answer is there is no right or wrong answer. There's no definite answer. You need to analyze and you need to choose what is best suited for your case, for your application, for your business operation. And who will make that decision? Should it be your team as a development team, system development team, data operator team, administrator team, or should it be the business management? What do you think? Okay, so whatever decision and whoever the decision would be made, usually we need to be very objective, right? We need to consider important criteria before making and proposing a solution. So let's have a look at these important criteria for choosing between AP or CP. So first, in terms of consistency versus inconsistency, if you choose to reduce some consistency, that means we allow some form of inconsistency to occur. So what would be the cost that we need to pay? What would be the price we need to pay when we allow inconsistency of the data to occur? That means when the data can be slightly outdated, right? When some users access the data and they may not see the most up-to-date version of the data. Would it cost? Would it have any effect to the business? This is what you have to consider. Or if you want to maintain high consistency, what would be the cost to achieve the very high consistency? Maybe you need to make sure that you invest appropriate technology, okay, and resources and so on. That would cost the business. So this is the first criteria. What would be the cost of achieving consistency? And what would be the cost if we allow inconsistency? Second criteria, in terms of availability. If we want to achieve high availability, how important it is. Is it okay for the system to be slightly unavailable for a short period of time? Or is it okay if we throw some errors saying that the system is not available for the moment and so on? So this is what you have to analyze. Because if you choose to let the system to be consistent, then we need to relax the system to be unavailable for some time, right? Then is that okay? And the next criteria is about how much latency can be tolerated. Okay, so latency means the system may be slow in response, right? And it may take some time for the system to respond to the user request. And that means you need to analyze how long time would be okay for the user to tolerate the system latency. And keep in mind as well that high latency would mean or would refer to no availability, right? Sometimes we think that when the system is not returning the data in a good response time, that means it has high latency. In some case, it's equal or similar to the system with no availability. And the last criteria to consider is whatever you are proposing, how complex your solution would be, okay, in terms of technical complexity in this case. And of course, it relates to the other criteria that we already analyzed, right? The complexity, the cost we have to pay, and the importance of trade-off or balancing this thing. Apart from the CAP theorem, there is also another theorem which is named as PACELC. It's a kind of extension to CAP theorem because actually in CAP theorem we focus on a trade-off between availability and consistency when there exists network partition, right? But the PACELC discusses also about the case when there is no network partition. There's no partition. That means the system still has network operating smoothly. But then, even that is the case of no network partition, the system still needs to trade off between latency and consistency. That means if you would like to guarantee high consistency, you are trading off with the latency issue. But if you want to reduce the latency, it means maybe you need to also reduce the degree of consistency of your system. And keep in mind, as mentioned in the previous slide, that high latency could be considered as no availability anyway, right? So you cannot just keep users waiting for the update or for the operation because you want to maintain very high consistency, and that causes very high latency as well. Okay, so let's summarize. At the end, what would we desire? And what would be our technical solution, technical recommendation? Okay, of course, ideally, we want high availability. And we definitely want our system to be highly consistent, right? But of course, we need to argue, right, that from the CAP theorem and from also another extension of the CAP theorem, we know that with a possible of network partition, we cannot have both high availability together with high consistency. So what should we do? Of course, in several situations, several systems and services, right? It is known that we want to make sure that the system is available to our users. We will not want the users to be told that now you cannot access the system, it's not available for the moment, you can try again tomorrow or something, if it is a good business that needs to run over the network on 24/7 all the time, right? We really consider availability to be one of the very important quality of service for the system. So we could consider providing high availability, that means low latency, right? Over consistency. But instead of none or zero consistency, right? We can consider what we call eventual consistency. So that means it's also a good balance to consider high availability with eventual consistency. We will discuss about what does it mean by eventual consistency in the next topic. Okay, before we end this lecture, let's consider your own project you have been working on with your team as part of the course. What do you think would be the best choice for your project between the AP and the CP? Or would it be better to consider as well the high availability with slightly lower degree of consistency? But as I already mentioned, different application requirements, different business scenarios, and so on would require different answers. See you in the next lecture.